Hello student, welcome to my channel The Learn Physics. I have already uploaded the 7 videos of chapter 1 to 7 of ncert Physics class 12. Now today I will be discussing the electromagnetic wave. Now our discussions are the introduction, displacement current, Maxwell equation of electromagnetic wave, characteristics of EM wave, the ratio of amplitude of electric field and magnetic field is give rise the speed of EM wave, and speed of EM wave is equal to 1 by root under mu naught epsilon naught, and energy density of EM wave and electric magnetic field, and finally the electromagnetic spectrum and numericals of ncert of all topics. Okay, now let's start. From chapter 4 of ncert physics, we know that a current carrying conductor produces magnetic field around it. We also know that two parallel conductors carrying a current experience a force, and in chapter 6 a time varying magnetic field produces electric field. Is the converse also true? Scientist Maxwell argued that was indeed the case. Not only current but also a time varying electric field produces magnetic field. While applying Ampere's circuital law to find the magnetic field around a capacitor, when an alternating source is applied in the capacitor, Maxwell noticed that Ampere's circuital law is inconsistent. He suggested an additional current called displacement current to remove this inconsistency of Ampere's circuital law. Now displacement current. When electric field varies with time, then a current is produced called displacement current. The displacement current ID equal to epsilon naught. This is the d phi E by dt, where phi is the electrical flux and epsilon naught the permittivity of the free space. Okay, now we have to express the relation between displacement current and conduction current. Look at this is a parallel plate capacitor. Instantaneous charge is plus q and minus q. So electric field at this point is equal to q divided by epsilon naught A. Now electrical flux in this region, look at this, if this is the area A, so phi E equal to, this is the E into A, so this is the Q by epsilon naught. Now displacement current ID equal to, look at this, epsilon naught, this is the d phi E by dt. So this is the epsilon naught, this is the dq by epsilon naught divided by dt. So look at this is the dq by dt. So look at this, dq by dt is the conduction current. So displacement current is numerically equal to the conduction current. While conduction current produced when electron flow through a conductor, and displacement current is produced when there is a time varying electric field. Okay, understood? Now Maxwell's equation of EM wave. The fundamental laws of electricity and magnetism are taken as the equations of electromagnetic wave or Maxwell's equations of electromagnetic wave. Now the equations are, first of all, the Gauss law of electrostatic, that is E vector dot ds vector is equal to q by epsilon naught, where q is the charge enclosed by the Gaussian surface. Now Gauss law of magnetism this is the B vector dot ds vector magnetic flux, this equal to 0. And now the Faraday's law of electromagnetic induction, look at this, this is the E vector dot dl vector, this equal to negative sign of magnetic flux by dt. Okay, and finally Maxwell ampere law, look at this, this is the B vector dot dl vector, this equal to mu naught, this is the conduction current plus epsilon naught d phi E by dt, so this is the displacement current. Okay, now ncert, the radius of circular plate of a parallel plate capacitor is 12 centimeter and distance of separation is 5 centimeter. Now it is charged by a current of 0.15 ampere. Now we have to calculate the rate of change of potential in the capacitor, displacement current, and will KVL applicable in this case. First of all, the capacitor of the parallel plate capacitor, look at this, C equal to epsilon naught A divided by D. Look at this, therefore C equal to 8.85 into 10 to the power minus 12, and this is the pi into 12 0.12 whole square and divide by this is the 0.05. Okay, this is almost 8 into 10 to the power minus 12 farad, so this is the 8 picofarad. Okay, now look at this, the rate of increase of potential in this capacitor. Now we know Q equal to CV. Now dq by dt, this equal to C into dv by dt. Now look at this, dq by dt is equal to charging current. This is the 0.15 and this is the 8 picofarad, that is 8 into 10 to the power minus 12, this is the dv by dt. Now look at this, this is the dv by dt, this equal to 0.15 divided by 8 into 10 to the power minus 12. So look at this, this is the 15 into 10 to the power 10 divided by 8. This is the 1.87 into 10 to the power 10 volt per second is the rate of increase of potential. Okay, now next, what is the displacement current? Now displacement current is equal to conduction current, so this is the 0.15 ampere, and will Kirchhoff's law obeyed, as Kirchhoff voltage law is based on conservation of energy, so Kirchhoff's second law will be applicable here. Now ncert 8.2, look at this, radius of a circular plate of parallel plate capacitor is 6 centimeter. Capacitance is 100 picofarad. Now a AC voltage of 230 volt 300 radian per second is applied in the capacitor. Now we have to calculate the RMS current and will conduction current is equal to displacement current, and magnetic field at a distance 3 centimeter from axis of the circular plate. Okay, first of all IRMS. So look at this, XC, this equal to 1 by omega C. Look at this, omega equal to, this is the 300 and C equal to 100 picofarad, so this is the 10 to the power minus 12. So look at this, this is the 10 to the power 8 by 3 ohm. Therefore RMS value of current, look at this, the RMS value of current is equal to Vrms by XC. So look at this, IRMS, this equal to 230 into 230 divided by XC, so 10 to the power 8 and this is the 3. So look at this, this is the 690 into 10 to the power minus 8, so this is the 6.9 into 10 to the power minus 6 ampere is the RMS value of current. Okay, now amplitude of magnetic field B equal to mu naught divided by 2 pi capital R square. This is the I naught into small r. Now look at this, I naught equal to root 2 into RMS. So look at this, this is the 4 pi into 10 to the power minus 7, and this is the 6.9 root 2 into 10 to the power minus 6, and r equal to 3 centimeter. So this is the 3 by 100, and look at this, this is the 2 pi and r equal to 6. So this is the 6 by 100, this is the square. Okay, look at this, 2 pi and 4 pi, so these are 2. The 2 into 6.9 into root 2 into 3 into 10 to the power minus 11 into 100, this divided by, this is the 36. Now this and this is the 12, and this is the 6. This equal to 6.9 root 2 by 6 into 10 to the power minus 11. So look at this, this is the 1.63 into 10 to the power minus 11 Tesla. Okay, this is the amplitude of magnetic field. Okay, now characteristics of EM wave. The electromagnetic wave consists of electric field vector and magnetic field vector perpendicular to each other. Their direction of propagation and perpendicular to the electric field vector and magnetic field vector. Look at this, the direction of propagation along x-axis, electric field vector along y-axis, and magnetic field vector along z-axis. Okay, now look at this, the electric field vector and magnetic field vector are vibrating in phase. Look at this, when electric field vector maximum, magnetic field vector also maximum. Next, poynting vector. The rate of transfer of energy per unit area normal to the direction of propagation of EM wave is called poynting vector. Now poynting vector is equal to 1 by mu naught, that is the E vector cross B vector. That is, look at this, the direction of energy transferred is perpendicular to the electric field vector and magnetic field vector, and poynting vector, the unit of poynting vector is joule per meter square into second. That is, this is the watt per meter square. Its dimension is, look at this, dimension of S is m t minus 3. Okay, the speed of EM wave is equal to omega by k, is equal to the ratio of amplitude of electric field and amplitude of magnetic field, and it is also equal to 1 by root under mu naught epsilon naught. Look at this, C equal to, this is the omega by k, and this is the E naught by B naught, and this equals to 1 by root under mu naught epsilon naught. Okay, understood? The EM wave obeys the inverse square law, that is, intensity of EM wave is inversely proportional to the square of the distance from the source. Okay, the energy density of EM wave is distributed half in electric field and half in magnetic field. So energy density in electric field is equal to energy density in magnetic field is equal to half of energy density of EM wave. Okay, now NCERT 8.4. Look at this, if EM wave propagates along the z direction, find the direction of B vector and E vector, and if new frequency of EM wave is 30 megahertz, we have to calculate lambda. Now poynting vector is equal to 1 by mu naught, this is the E vector cross B vector. Now look at this, this is the k cap, S vector is directed along the direction of z axis, this is the k cap. So look at this, I must be I cap, and look at this, B must be j cap. So direction of electric field vector is along x-axis and magnetic field vector along y-axis. That is in the yz plane. Okay. Now lambda. We know lambda equal to c by nu. Now c 3 into 10 to the power 8, and look at this. This is the 30 into 10 to the power 6. So look at this. This is the 10 meter is the wavelength of the wave. Okay. Next. Now look at this. The frequency band of EM wave is this and this. We have to calculate the wavelength band. Now we know C equal to 3 into 10 to the power 8 meter per second. Now for lambda 1, this is the C by nu 1. So C 3 into 10 to the power 8 divided by 7.5 into 10 to the power 6. So look at this. This is the 300 into 10 to the power 6 divided by 7.5 into 10 to the power 6. This and this cancel out. And now look at it. This and this is the 40. So this is the 40 meter is lambda 1. Okay. Now lambda 2 equal to C by nu 2. So look at this. C 3 into 10 to the power 8 and nu 2. Now nu 2 equal to 12 into 10 to the power 6. Now this is the 300 into 10 to the power 6 by 12 into 10 to the power 6. Cancel out. And now look at this. This is the 4 into, now this is the 4 into 100. So this is the 25 meter. So the wavelength band from 25 meter to 40 meter. Okay. Understood? Now 8.7. The amplitude of magnetic field is 510 nanotesla. Now we have to calculate the amplitude of electric field. We know from the characteristics of electromagnetic wave, E naught by B naught, this equal to C. Okay. So E naught equal to, this is the C B naught. Now this is the 3 into 10 to the power 8 and this is the 510 into 10 to the power minus 9. So this is the 3 into 51 volt per meter. So this is the 153 volt per meter. Okay. No problem. Next. Now we have to express the relation C equal to E naught by B naught. Suppose an electromagnetic wave propagates along the positive direction of x-axis. So electric field vector is directed along y-axis and magnetic field vector directed along z-axis. Now the electric field vector, this is the Ey equal to E naught sine, this is the kx minus omega t, and magnetic field vector Bz, this is the B naught sine, this is the kx minus omega t, where omega by k is the speed of the EM wave. So C equal to omega by k. Okay. From Faraday's law of electromagnetic induction, we know E vector dot dl vector, this equal to negative sign of d phi, this is the d phi b by dt. That is, changing magnetic field produces electric field. So from this expression we can prove that a time varying magnetic field produces space varying electric field. So look at this. This is the del Ey by del x is equal to minus del Bz by del t. Now put the value of Ey and Bz. Now this is the Ex, so this is the E naught sine, this is the kx minus omega t, and this equals to, now this is the B naught sine, this is the kx minus omega t. Okay, this is the E naught k cos kx minus omega t, and look at this, this is the B naught omega and cos, this is the kx minus omega t. Now this and this cancel out. Look at this, this is the E naught by B naught. So this equal to omega by k equal to c. Okay, understood? Now look at this NCERT 8.8. Look at this, amplitude of electric field vector is given, frequency of EM wave is given. We have to calculate the amplitude of magnetic field, angular frequency, angular wave number, wavelength, and finally Ui and Bz. Okay, now look at this. First of all, E naught by B naught, so this is the C. Therefore, B naught equal to E naught by C. This is the 120 and this is the 3 into 10 to the power 8. So look at this, this is the 40 into 10 to the power minus 8. This is the 400 nano Tesla. Okay. Now look at this. Now look at this omega. Now angular frequency omega equals to 2 pi nu. So look at this, this is the 2 pi into, this is the 50 into 10 to the power 6 radian per second. So this is the 100 pi into 10 to the power 6 radian per second. Okay. Now k, wave number. Now we know omega by k, this is the c. So k equal to omega by c. Look at this, omega equal to, look at this, omega equal to pi into 10 to the power 8 and c equal to, and c is the 3 into 10 to the power 8. So this is the pi by 3. Okay. So k becomes pi by 3. Okay. Now finally lambda. Now k equal to, this is the 2 pi by lambda. So lambda equals to 2 pi by k. So look at this, 2 pi divided by pi by 3. So this is the 6 meter is the wavelength. Okay. Now we have to express B vector, E vector and B vector. Now from above discussion we get E naught equal to this, B naught equal to this, omega equal to this and k. Now we have to express the electric field vector and magnetic field vector. Okay. Now look at this, if electric field is oscillates along y-axis, magnetic field oscillates along z-axis, so direction of propagation will be the x-axis. So look at this, this is the Ey equal to, this is the 120 Newton per Coulomb and sine, this is the sine omega, omega now, this is the pi, so this is the pi x by 3 minus omega t, omega means pi into 10 to the power 8 into t. Okay. Now Bz equal to, this is the 400 nano Tesla sine, this is the pi x by 3, pi x by 3 minus pi into 10 to the power 8 into t is the equation of electric field vector and magnetic field vector. Okay. Now we have to establish the average energy density in electric field is equal to average energy density in magnetic field, and this equal to half of energy density of EM wave. Look at this, the instantaneous energy density of EM wave is U equal to, look at this, this is the half epsilon naught, this is the Uy square plus this is the Bz square by 2 mu naught. Okay, where Ui is equal to, this is the E naught sine, this is the kx minus omega t, and Bz, this equals to B naught sine, this is the omega t, sorry, this is the kx minus omega t. Okay. Now put this value Ui and Bz. So U equal to, look at this, this is the half epsilon naught, this is the E naught square, this is the sine square omega sine square kx minus omega t plus this is the B naught square sine square, this is the kx minus omega t by 2 mu naught. Okay. Now look at this, the average energy density, this equals to half epsilon naught E naught square. Now average value of sin square theta is equal to half, so this is the half, and this is the B naught square by 2 mu naught, and this also half. So average energy density, this is the 1 by 4 epsilon naught E naught square plus 1 by 4, this is the B naught square by mu naught. Okay, we know C equal to, this is the E naught by B naught, and C square equal to 1 by mu naught epsilon naught. Now we replace mu naught. So look at this, here 1 by mu naught equal to 1 by mu naught is equal to epsilon naught C square. Now look at this, this is the 1 by 4 epsilon naught, this is the E naught square. Now 1 by mu naught is the 1 by 4 epsilon naught C square, this is the B naught square. Now look at this, C square B naught square, look at this, C square B naught square equal to E naught square. So this is the 1 by 4 epsilon naught square E naught square plus 1 by 4 epsilon naught square E naught square. So this is the half of epsilon naught E naught square. Okay. So look at this, the energy density of EM wave is half epsilon naught E naught square. Okay. Now half of, look at this, this is the E naught square into 1 by mu naught into C square. Now look at this, this by this square, this is equal to B naught square. So look at this, this is the B naught square by 2 mu naught. Now the energy density of EM wave is half epsilon naught E naught square equal to B naught square divided by 2 mu naught. So energy stored in electric and magnetic field is equal, and half of energy stored of EM wave. Okay. Next, now look at this 8.10. The frequency of EM wave is 2 into 10 to the power 10 Hz. Amplitude of electric field is given. Now we have to calculate lambda, amplitude of magnetic field, and we have to prove energy density in electric field is equal to energy density in magnetic field. Okay. Now first of all, the lambda. So lambda equal to C by nu. So this is the 3 into 10 to the power 8 divided by 2 into 10 to the power 10. So this is the 1.5 into 10 to the power minus 2 meter. Okay. Now amplitude of magnetic field. Look at this. Now B naught equal to E naught by C. E naught equal to, look at this, 48, and this is the 3 into 10 to the power 8. So this is the 16 into 10 to the power minus 8. So this is the 160 nano Tesla. Okay. Now energy density in electric field. Now energy density in electric field E equal to half epsilon naught E naught square. Now we know E naught equal to C B naught. Therefore this becomes half epsilon naught C square B naught square. Now mu naught epsilon naught equal to C square. Therefore look at this, 1 by epsilon naught equal to epsilon naught C square. Now this is the 1 by mu naught. So this is the B square by 2 mu naught. Therefore energy density in electric field is equal to energy density in magnetic field. Okay. Now look at this, the equation of EM wave is given this equation. Now if we compare this equation, look at this, this is the E naught cos, this is the ky plus omega t. The amplitude of electric field E naught equal to 3.1 Newton per coulomb. Now K equal to 1.8 radian per meter and omega equals to 5.4 into 10 to the power 6 radian per second. Now we have to calculate the direction of propagation of the wave. Look at this, this is the positive side, so the wave propagates, along the negative direction of y-axis. So this is the negative y-axis. Okay. Now lambda. We know 2 pi by lambda, this equal to k. So lambda becomes 2 pi by 1.8. This is the meter. Okay. Now what is the frequency? Now 2 pi nu is equal to omega. So nu equal to omega by 2 pi. So this is the 5.4 into 10 to the power 6 divided by 2 pi hertz. Finally, strength of magnetic field. We know C equal to E naught by B naught. Therefore, B naught equal to E naught by C. So this is the 3.1 into 3 into 10 to the power 8 Tesla. Okay. Now we have to express the equation of magnetic field. So look at this, the magnetic field becomes, look at this is the B naught, this is the 1 into 10 to the power minus 8 Tesla, and cos, this is the 1.8 radian per meter y, plus 5.4 into 10 to the power 6 into 10 to the power 6 radian per second, and this is the T, this is the expression of magnetic field. Okay, now EM spectrum. According to increasing order of wavelength, the EM spectrums are gamma ray, X-ray, ultraviolet ray, visible ray, infrared wave, microwave, and radio wave. These spectrums have tremendous use in our civilization. Many thanks for watching this video. This video will extremely helpful for you for your preparation in CBSE, Main, NEET and Advanced. Please like, share and comment on this. And if you are new, don't forget to subscribe my channel to get the new videos to boost up your preparation.